Good morning, children. Today, I would like to tell you about rate equations for four-level lattice system. Let us see the presentation. Okay, before that, we will see the question and answer session. What are the three requirements of laser action? I will repeat again. What are the three requirements of laser action? So here we have the three requirements are first one, system must be in a state of population inversion. System must be in a state of population inversion. The excited state of the system should be in metastable state. The excited state of the system should be in metastable state. And finally, atom should be in a lower energy state. Atom should be in a lower energy state. Rate equations for four-level system. This is the diagram, and here we have four levels: level 4, level 3, level 2 and level 1. So level 1, it is the ground state and higher energy level. This is highly excited state. And level 3, it is here higher metastable state. This is lower metastable state, or we can say lower laser level, and this is upper laser level. So here so this is the higher excited state. The atoms which are stay a very less time, very short period, the atoms will be stay here. And here this is the metastable state, which the atom lived here a long lifetime and up to 10 power minus 8 seconds. So here lower metastable state, lower laser level. Here also the atoms stay very short time. Now let us give the pumping. So whenever we are using pumping here, the atoms which are present in the ground state, they absorb this radiation and it will go to the higher energy level. From here to here, these atoms, they come very fast here because this is the very short-lived energy level. Now here whenever the atoms which are coming to the level 3, here we can observe the lasing action. We can observe stimulated emission, or we can say it is laser beam. Okay, this is the because of metastable state, population inversion due to pumping, the lasing action can be seen here. And from level to lower laser level, from here to here, we can observe very fast coming back to the ground state. The atoms coming very fast here. Okay. Already we have seen all these things. Now here level n, let n1, n2, n3, n4, these are the number of atoms present in level 1, number of atoms present in level 2, number of atoms present in level 3, number of atoms present in level 4 respectively. So let us see the change in population in level 4, which is describing by the equation rate of change of level 4. So here dn4 by dt is equals to omega p n1 minus n4 minus t4 n4. Here omega p represents the laser levels between level 1 and level 4. Omega p laser, here we can observe the from level 1 to level 4 levels, energy levels between level 1 and level 4 represents the omega p, where omega p n1 minus n4, this represents the net rate of stimulated transition occurring between level 1 and level 4, which is caused by the pump of the beam. So here T4 it is nothing but net realization rate from level 4 to level 3, 2 and 1. So that is T4 is equals to T4 3. That means transitions from 4th level to 3rd level plus transitions from 4th level to 2nd level, transitions from 4th level to 1st level. So total T4 which is equals to T4 3 plus T4 2 plus T4 1. Similarly, let us see the rate of change of population in level 3, that means N3. So rate of change of population, which is represented by dN3 by dt, which is equals to T43, that means transitions from level 4 to level 3 N4 plus omega L. So here the energy levels between level 2 to level 3. Here omega L represents energy levels between 2 and 3. So N2, number of atoms present in 2 level, second level, number of atoms present in third level minus T3 N3. So this is equation number 2. Here T3 represents transitions from third level to second level, transitions from third level to first level. So T3 equals to T32 plus T31. So similarly the rate equation for N2 and N1 would be, so rate of change of population in level 2, which is equals to T4 to N4 plus omega L, N3 minus N2 minus T21 N2 plus T3 to N3. So here omega L represents the energy levels between level 3 and level 2. So rate of change of population in level 1 dN1 by dt equals to omega p N4 minus N1 plus T41 N4 plus T31 N3 plus T21 N2. This is equation number 4. So here rate of change of population in level 1 plus level 2 plus level 3 plus level 4, which is equals to 0. So which is a constant with the requirement that total number of atoms. So n is equals to total number of atoms present in level 1, 2, 3 and 4. So which is a constant. Now at steady state, we must have dN1 by dt equals to dN2 by dt equals to dN3 by dt equals to dN4 by dt, which is equals to 0. What is a steady state? So here with respect to time, the system does not change its properties, is nothing but steady state. So rate of change of level 1 equals to rate of change of level 2 equals to rate of change of level 3 equals to rate of change of level 4, which is equals to 0. So using this equation, we will obtain N4 equals to. So by keeping dN4 by dt equals to 0, we will obtain rate of change of number of atoms present in level 4, which is equals to omega p by 2 omega p plus T4 n minus n2 minus n3. So using the equations 8, 6 and 2. 8 and 6 and 2 and 3 with equation 7 will obtain, and now by using equation number 8, 6 with 7 we will obtain N3 omega L plus T3 into 2 omega p plus T4 by omega p plus T43 plus N2 T43 minus omega L 2 omega p plus T4 by omega p, which is equals to T43N. Now by using equation 2, 3 with 7, we will obtain here N3 T42 minus T32 plus omega L 2 omega p plus T4 by omega p plus N2 T21 plus omega L 2 omega p plus T4 by omega p plus T42, which is equals to NT42, which is equation number 10. Now, so we have to solve the above equation to obtain the population difference between levels 3 and 2. Here we need only the population difference between levels 3 and 2, because we can obtain the laser beam with these two levels only, from 3 to 2 transitions. That means by solving the above equation, we will obtain N3 minus N2 by N. That means rate of change of population in level 3 and level 2, which will give the laser action, which is equals to, by solving the above equation, we will obtain T21 T43 minus T3 T42 minus T32 T43 into T43 T21 plus T32 plus T3 T42 plus 2 omega p plus T4 by omega p T3 T21 plus omega L 2 T42 plus T43 plus 2 omega p plus T4 by omega p into T31 plus T21 whole power minus 1. So this is the required equation for the population difference between levels 3 and level 2. So at below threshold of oscillation, omega L is equals to 0. That means the rate of change of population at below the threshold, by using omega L equals to 0, we will obtain 1 minus beta omega p T43 by T4 T3 by 1 plus beta plus 2 3 by T4 omega p T4 3 by T4 T3, where beta equals to T3 2 by T21 plus T3 T4 2 by T21 into T4 3. So for a good laser action, one must have the condition T3 should be less than T43 and T21 greater than T32. That means transitions from 3 should be less than transitions between 4 to 3, and transitions between 2 and 1 should be greater than transitions between 3 to 2. So that beta is equals to 0. Also we have the condition T4 should be similar to T43. Therefore, the rate of change of population in level 3, which is equals to omega p by T3 by 1 plus omega p by T3. So this is the required rate of change of population to get the lasing action for the 4-level laser system. Now, the question is, what is the unique property of laser? What is the unique property of laser? Thank you. Okay, children, thank you.